Question 1. Given a metal bar with an initial temperature at 25 degrees Celsius is immersed in a container of boiling water. It was observed that the temperature of the metal bar increased 3 degrees Celsius in 1 minute. Determine the time required for the metal bar to reach 85 degrees Celsius.
Okay, from the question, what we get from the question, so we take out to the some information. Okay, first, the given is initial temperature, which is T0 is 25 degrees Celsius. Surrounding temperature is represent for TS is 100 degrees Celsius. Temperature after 1 minute is 28 degrees Celsius and T time is 35 degrees Celsius. Okay, based on the Newton empirical law, heating or cooling, dT over dt is kT minus Ts. So, we get dt over dt kT minus 100 because Ts is temperature surrounding. Okay, and we move T minus 100 to the left hand side and dt to the right hand side, and we want to integrate for both sides and we get like that. Okay, after we integrate both sides, so how we want to find the solution, right? Oh no, so we just integrate and get ln T minus 100 equals to kT plus C. So to eliminate the ln, so we just add exponential at the both side and get exponent ln T minus 100 equals to exponent kT plus C. Since exponent kT plus C means exponent kT times EC. Okay, first, since EC is a constant, we just let EC equals to P because the value is constant, so we can just let, and that's mean T minus 100 is equal to exponent kT times P. T equals to P E kT plus 100 because negative 100 from the left hand side we move to the right hand side. Okay, so now we determine value of P. First step, when T0 is 25, so we just use the formula T0 equals to PE P exponent K0 plus 100, and B, T0 is 25 and 25 equals to PT plus 100, and move the 100 to the left hand side, we get P value which is negative 75. So at the T times negative 75 exponent KT plus 100, now we determine the value of K. First, when T1 equals to 28, then T1 equals to negative 75 exponent K1 plus 100. So we substitute being 28 equals to negative 75 exponent K1 plus 100, and we get exponent K equals to 72 over 75. So we add the ln at the both sides because we want to cancel the exponent, and B, ln exponent K equals to ln 72 over 75. So we just cancel ln and exponent and just maintain K, and K equals to ln 72 over 75, and we get the value of K which is negative 0.040x2. Next step, when T time is 85, then T time is equals to negative 75 exponent negative 0.040x2t plus 100, and we substitute dt with 85, and we get 50 equals to positive 75 exponent negative 0.0 is 2t, and we add the ln to both sides to cancel the exponent to find the value. Okay, we get negative 0.082t equals to ln 1/5. So the value of t is approximately 39.53. The time taken of the water to rise from 25 degrees Celsius to 85 degrees Celsius is approximately 39.4 minutes.
Question 2 given is a tank contains 300 liters of fluid in which 20 grams of salt is dissolved. Brine containing 1 gram of salt per liter is pumped into the tank at a rate of 5 liters per minute, and the well-mixed solution is pumped out at the same rate. Find the amount rate of gram of salt in the tank at time t.
So initially the tank has filled with 300 liters of fluid in which 20 grams of salt in it already dissolved in the fluid, and somehow brine that containing 1 gram of salt per liter is pumped into the tank at a rate of 5 liters per minute. And then the whole solution being well mixed. The solution actually are the fluid with 20 grams of salt dissolved, and then brine that containing 1 gram of salt per liter. All of that being mixed and then pumped out at the same rate, which is 5 liters per minute. So the question actually was very easy. It just asked us to find the amount of salt in grams at the time t in the tank. So done with highlighting our questions. So next, okay, this is the solution. So what we have to keep it in our mind that we have to find AT based on the question. It stands for AD, where it represents as amount of salt in gram in the tank at time t. This is what we have to find. Okay. So we can do this by forming a differential equation. Just what you can see on the slide. This is our differential equation. dA over dt equal to rate in minus rate out. So dA over dt is what we have to look for, the changes of amount of salt. And this is actually makes sense because our rate in, we have some salt that were going into the tank, and we subtract it off with the salt that going out from the tank. Okay, but the question here is how to find rate in and how to find rate out. Okay, well, this is very easy. It's already been mentioned in the question. That's why it's very important to highlight our key points in the equation. Okay, we can go back. Okay, our rate in, we just can multiply the concentration of brine, which is 1 gram per liter, with 5 liters per minute. Okay, and this is how we get below here. So here we will have 5 gram over minute. That's because we have cancelled out the little. So we have gram over minute, 5 gram over minute. Same goes with the rate out. Okay, our rate out is equal to 80 over 300 gram over liter multiplied with 5 liter over minute, where the result is 80 over 60 gram over minute. Okay, same goes with the previous one. We cancel out the liter. That's why we just have the gram over minute. So done finding our rate in and rate out values. So we just have to plug in these values into our differential equation. So this is what we get. Okay, this is what we get after finding these two. We just substitute into the equation. But if you realize this is not in the standard form, so we have to rearrange it to make it look better in the standard form. So we in the next slide. This is how it will end up. dA over dt plus 80 over 60 equal to 5. Actually, there are many ways to solve this, but I'll be using integral function here to solve this equation. So remember that our integral function is the exponential to the integral of the coefficient in the equation. So in this case, we have our coefficient here is equal to 1 over 60. So that's why we have here exponential to the integral 1 over 60 dt, where it gives us exponential to the t over 60. Okay, after this, like always, we just have to plug in all the needed value, and then it lead us to this equation where we just have to integrate the 5 here, and this is what we will have: 300 exponential to the t over 60 plus c. Okay, make sure you didn't forget this c since we have integration here. This is very compulsory to do it. Okay, but again, as you can see in this equation, it actually in not a good shape. I mean, the form is not suitable for us to write our final answer. So again, we need to rearrange the equation. Okay, and actually in the next slide. So this is how it goes. I have rearranged the equation, and this is the result. But this is not the final answer, because we have to find our c, the value of c, which is very simple. We just have to subtract the initial value of our salt, which is 20 gram, with the with the initial fluid in the tank, which is 300 liter. So obviously we will have negative 280. So as simple as that, we just have to substitute again the value into our equation here, and this is our final answer. As simple as that. So in conclusion, our answer, the amount of salt in gram in the tank at time t, which is 80, is 300 minus 280 exponential to the negative t over 60. Okay, this is our conclusion for the question 2, our answer.